Okay, good morning class. So today I gave you homework. The homework was the trigonometry, the compound and double angles. You had to do the revision exercise on page 91, correct? Right. This we're going to leave probably for Wednesday, since you are writing on, you're writing an assignment tomorrow, your investigation for the year. Also you have written on Friday your first class test, the first of many to come. As I see the need for you to write it, so that you can realize what you know and what you don't know. And according to what you got now, we still don't know many things. Okay, not a joke. For some of you it is, because we all now got for once the same things. No? Otherwise you can see clearly who's working and who isn't. But now it looks like the people that normally works isn't working either. So you're all okay now. Yes, you think that's nice. Think it's a joke? I'll refer your parents to this video. Just write the date down. Your parents, because when your parents come and talk to me, it's as if you guys are taking your life serious, your math serious, which is never the case here. No? Because when the parents come to me, they say, no, you know, my daughter is in your class and whatever. They must first show me a photo of who you are. Okay, then the parents are ready to know this guy is not doing his work and all this. No? But it's fine. This is where we're at. This was class test 1, supposed to have been March 2020, which is not that, okay? People, we are told in number 1, CD is a tangent to the circle ABDEF at D. So if this is a tangent, what do we know? We know many things. Okay, we know that D4 is equal to angle E2. Not so. Then we are told that this is also the same as which angle? Should be angle A as well. Not so? Then we are told that chord DE, chord AB is produced to C. AB is produced to C. Chord BE cuts chord AD in H. Chord EF and FD in G. AC is parallel. So AC is parallel to FD. If that's parallel, what do we know? The alternate angles are equal. So this angle and that angle are the same. Can you see that, people? Alternate angles. And many other things we can determine from that, like your co-interior. I don't see any corresponding, so no corresponding there. Then we are told that if FE is equal to AB. So if that is the case, what do we know? That angle D1 is equal to angle D3. Why is angle D1 equal to angle D3? Because equal chords obtains equal angles on the same side. Not so. Did somebody take a copy for? Yes. Okay. Right. Then we are told that angle D1 is equal to Y. Well, D4 is X. D1 is Y. D4 is X. Determine 3 other angles that are equal to X. Okay. So 3 other angles that's equal to X. So we already see that A is X. Why is angle AX? Tan chord theory. Not so. Then we also highlighted it that E2 is X. Why is angle T2X also tan chord? But some of you wrote angles in the same segment, full most. No? And then another angle that's equal to X? T2. Why is T2X? Alternate angles. So T2 is X, alternate angles. And when you write alternate angles, you must say DF is parallel to AC. Okay. 6 marks, people. Believe it or not. So what I'm going to do is I'm just going to pull this up here. I'm going to leave that the markings on the diagram. Just going to take this off here. Okay. Let's use red now for 1.2. In 1.2 they said prove that triangle BHD, so in triangle BHD and triangle FED. Okay, so BHD this triangle here and triangle FED. Okay, so from that, what do we know already? From those two, we know that D1, I've highlighted this already, is equal to D3. Why is D1 equal to D3? Equal chords subtends equal angles on the same side. So that's 1. What else do we know? We know that angle B2 is equal to angle F. Why is it equal to angle F? Angles in the same segment. Then H2 has to be equal to the combination of E1 and E2. Not so? So let's write that down. And when you prove similarity, we just need to prove that two angles are equal. Huh? So in the first case, it's going to be B2, or we could have worked with the sides. B2 is equal to angle F, angles in the same segment, and it's coming from arc BE, DE, supported by that arc, okay? So I'm just going to make that marking here, make a dot here. Then we know that angle D1 is equal to D3, which is equal to 1. Okay? These are equal chords. Subtends equal angles on the same side. Okay? So that's enough to then say that H2 has to be equal to E1 and 2, which is FED. Why? Because it's a third angle of triangle. Okay. So therefore, triangle BHD is similar to triangle. So you go B corresponds with F, H corresponds with E, and D corresponds with D. And yes, that is the correct order. Angle, angle, angle. Okay. So we're almost certain that there's going to be a distance question to follow this. So I'm going to keep this part of it, okay? You don't do the same in the exam and erase all your work afterwards, no? I'm just doing this to over the space, okay? And the last one, hence or otherwise prove that. And here you can see clearly it's dealing with lengths. Okay. So 1.3. So we can say that BH over FE is equal to HD over ED equals BD over FD. Why? Corresponding sides in proportion. Okay. So BH, they want AB. We don't have AB here. But if we look at AB from the diagram, AB is the same as FE. So do they have FE? No. FE is equal to? Okay, wait. BH. Yeah, they want BH. They want FD. They want BD. And they don't have FE. No? So you all agree it's this here that I need to work with. Okay, so it's going to be FD, so let's cross multiply. So FD times BH is equal to BD times FE. But FE is the issue, not so. But we know from the diagram that FE is equal to AB. Why? It was given to us. Therefore, FD times BH is equal to AB times BD. Okay, 2 marks. Alright. Okay, I think I need to do it. Alright, so number 2. We are told in the figure alongside triangle ABC, D and E, as D on E and BC. Okay. In the figure alongside ABC as D and, suppose it be N. Probably that is why you guys got what you got. No? Suppose I've read and. It has D and E on BC. Okay. Makes sense now. DB is DB 6. DC is 9. AT over TC is as 2 over 1. AT, so it's 2K and K. And AD is parallel to TE. So if these lines are parallel, what do we know? We know that AT over TC is equal to DE over AC, EC. And going this way as well, in this triangle. That over this will be this here over that. Okay? And all these variations that goes with it as well. So the first question says, write down the numerical value. It doesn't give you a reason. So they want the numerical value of CE over ED. So CE over ED is the same as CT. What is a T? CT over TA. Using a proportionality theorem. So that is going to be CE. It's going to be K over 2K, which is 1 over 2. Okay. Number 2. So in other words, this here will be A and 2A. That's all. And that's of course 9 centimeters. So in other words, I can actually work out what A is. Not so? And that's where number 2 comes into play. The question says, show that D is the midpoint of EB. So in other words, I must show that DE is going to be a length of, if D is the midpoint of BE, then I must show that DE is equal to what? 6. Not so? So there we got 2A. So we know that 2A plus A has to be equal to, 2A plus A has to be equal to what? 9, yes. And what is 2A plus A? 3A. 3A and 9 divided by 3 is 3. So DE is 2 times 3, which is 6. So since DE is equal to BD, which is equal to 6, therefore D is the midpoint of B. Okay, makes sense, people? So this is the midpoint here. So this is going to be 6 here, and of course this is going to be 3 centimeters. Alright, let's go to the next question. Well, let me know now what I haven't taught you yet. Did I teach you the stuff yet? Huh? Haven't, okay. We'll check exactly which video this came out, which lesson. Figure 2.3. In question 2.3, the question says calculate the length of TE if FD is 2 centimeters. So we all can see FD is 4. Not so? Because of the midpoint here. But how do we label this? We must first say that BD is equal to DE. Why? So we prove that D is the midpoint. So that is equal to that. Then we know that if D is parallel to DE, where do we get that from? From the fact that those lines are parallel. That was given. So we can conclude therefore TE is twice FD, which is 4 centimeters. Why? Because it's the converse to the midpoint theorem. You can't just say midpoint. If it was given like this, with that being equal and that being equal, then this is twice that and that lines are parallel, midpoint theorem. However, if you got that being parallel and those lengths being equal, if that's the information you got, then we must use the converse theorem to the midpoint. The converse to the midpoint theorem. Okay. See, nobody got that question right. And then 2.4. 2.4, they want the numerical value of the area we know is a P here. They want the area of triangle ADC over the area of triangle ABD. So if you're looking at ADC, the triangle, okay, and triangle ABD, okay. You take a triangle and you now make this flat here, or parallel to the horizontal. We can come with a perpendicular item. Let's call this perpendicular. Why am I going with this? Because it's shading a vertex on top. Can you see that? So I can get a corresponding what's the name? Height, the common height there. So the area of triangle ADC. So it's ADC. It's going to be half base, which is DC, times height, which is perpendicular there, over half. For triangle ABD, it's going to be your base, which is BD, times your perpendicular height, which is that. People, that cancels, that cancels. So DC, what's the length of DC? 6 over BD, which is, no, sorry, it's DC, which is 9, over BD, which is 6, 3 over 2. Okay, now some of you know already, when it's shading a perpendicular, we're shading a vertex on top there, we can draw a perpendicular height there. So if you knew that already, you don't have to do all of this here, you can go straight into that solution. Okay, sorry about that. Alright. And the last one. Sorry? Okay, right. Finish? Okay. The next one they want to know, I think it's blue out here. Let's leave it in, bit idea. Okay, they want to know the area of triangle TEC. You go T, EC. You see that triangle there? And triangle ABC. So it's A, B, C. This is the whole triangle. You see the big triangle? You all agree? You all understand? What do you know about those two triangles? What are they sharing? Yeah, the previous one was sharing a common height. This is sharing a common angle there, angle C. Can you see that? When you're sharing a common angle, you use the sine rule. The sine rule says it's going to be half AB sine C. So you have two lengths and included angle. So for this triangle here, what are my two lengths? I got the half TC times EC times sine of angle C. Okay, and this is all over half. It's going to be AC times BC sine of angle C again. As you can see, it is sharing a common angle. Halves cancel, sine C's cancel. So the length of TC is marked with a K. Can you see that? The length of TC is marked with a K, so it's K times EC. The length of EC we worked out to be 3, or I could have said A over the length of AC, which is 3K, times the length of BC. Since I used 3 here, I'm going to use the length, which is 50. if I had written A here, then this length would have been A 5A. Okay. So what do we get here? The k's of course cancel, and the 3's cancel. So the answer is 1/50. Alright. Not so difficult, people. You're going to get another test on this soon. Okay, so please go learn your work. Will be to your own benefit. Okay. As indicated, your similarity, your trigonometry revision exercise I cut already to discuss with you people. But at this point, I think that took preference. Okay. To show you how important it is to do your homework. Okay. Yes? I don't know. You're talking about your mini exam? I don't know. The timetable is out already. The draft is out, so they're still finalizing the dates. Okay. But you're going to write a 2-hour paper for 100 marks. Okay. And you're going to write on the topics that's taught so far. Sequence and series, and this one that you did fairly badly as a class, and your trigonometry as well. Okay. So this whole week's trigonometry is going to be in there as well. Okay. So for homework I gave you the 3 formulas you have to derive from the cos A minus 2, cos of A minus B. Okay, the compound angle. Then you have to derive a formula for cos A plus B, which is cos alpha cos beta minus sin alpha sin beta. You are going to get one of these 3 in the exam. I'm telling you now already. Okay. So you're making notes as if you didn't do it over the weekend. Sad again to note that. Sin alpha minus beta can be written as sin alpha cos beta minus cos alpha sin beta. And then sin alpha plus beta can be written as sin alpha plus beta can be written as sin alpha cos beta plus sin beta cos alpha. So what I'm going to do is I'm going to write that formula down. Okay, so it's going to be sin alpha plus beta. That can be written as sin alpha cos beta plus sin beta cos alpha. Okay. Now if you have a negative here, sin alpha minus beta, then it's simply sin alpha cos beta minus sin beta cos alpha. Okay. The other formula is cos alpha plus beta is going to be cos alpha cos beta, opposite sign, minus sin alpha sin beta. Okay? And if that is negative, then that will be positive. Okay? So let's look at a couple examples regarding these formula. I'm going to look at the work example on page 94. Worked example on page 94. Bear in mind those formula, okay? These formula is given in the exam as well. Okay. Okay. So here we are told the compound angle formula are used to simplify the following examples. Simplify the expression. So we got sine 20 cos 40 plus cos 20 sine 40. Okay, so what do we note here? What is sine? Now, in terms of 20, you must see that is an alpha for argument's sake. So this is the same as saying sine alpha cos beta. So if alpha is 20 and beta is 40, we're seeing sine alpha cos beta plus cos alpha sine beta. So which one does that remind us of? Sine alpha cos beta plus sine beta cos alpha. So it's going to be sine alpha plus beta. Does it make sense? Who's confused? Do it again. Okay. I think I must rather take this out here. Let me write it apart, okay? So if this is a sine alpha minus beta, is going to be sine alpha cos beta minus sine beta cos alpha. The other one is cos alpha minus beta. That can be written as cos alpha cos beta plus sine alpha sine beta. Okay, see, cos remains the same. And cos, but the sign is different. For sine, the sign is the same. Okay. So let's look here again. If we got sine alpha cos beta, which is one of these two. But I have a plus, so it's that one. Does it make sense, people? Okay. So what is alpha in this case? 20 and your beta? 40. So in other words, this will simply be what? Sine alpha, which is 20, plus 40. What's 20 plus 40? 60. And then we take it to its special angle. So that's simply going to give us sine of 60. My special angles, do not use your calculator, try and work with the special triangles. You guys will be writing an NBT for those of you who want to apply Stellenbosch and UCT. You guys know about the NBT you should be writing? Right? That exam, maths exam, is a 3-hour paper. However, no calculators to be used. So when it comes to trigonometry, it's all about your special angles and your identities. Okay? So learn, know how to do these things. Okay? So what is sine of 60? Sine is opposite over hypotenuse, so it's going to be the root of 3 over. You guys okay with this? Any questions? Let's look at the example 2. Example 2. Can you all see on the board? In example 2, we are given cos of 50, cos of 140, minus Sine of 130, sine of 220. So what can happen here? 50 is in, okay. However, 140, 130 and 220, I'm going to reduce that all to acute angles. Which means to say they're in the first quadrant. Not so. So 140 is in which quadrant? Sorry? Second quadrant. How do we get into the second quadrant? 180 minus something, not so. Sine 130 is in which quadrant? Second quadrant. How do we get in second quadrant? 180 minus an angle. 220 is in which quadrant? Third quadrant. So it's going to be sine 180 plus an angle. Work that out, please. I'm going to drop the calculator here at this point. Okay, so it's 180 minus what? 40. 180 minus 50. 180 plus 40. So what do you notice here? Is the remains cos of 50 times. So the all stations to Claremont diagram still applies. For those of you who thought, oh yes, we grade 12. So we can forget about this now. Raise it again, okay? 180 minus 40 is in which quadrant? Second quadrant. Cos positive or negative? Negative. So here goes negative cos 40. Minus. 180 minus, which quadrant is this in? Second quadrant. So that would be sine 50. Remember that besides it's negative here, that sign is positive in the second quadrant. And positive times that negative are scratched out is going to be negative. So it's negative sine 50 times 180 plus, which quadrant is that in? Third quadrant, sine positive negative? Negative. Okay. So what I got here is negative cos 50, cos 40. Negative times negative is positive, so it's positive sine 50. Both is sine 50. Sine 50, sine 40. Okay. Sorry about that. But looking at these identities, what do you notice? They are all positive in front of it. Not so? So how do I get a positive in front of that? Sorry? Take out a common factor. Yeah. Common factor of negative. I'm then left with cos 50, cos 40. Minus sine 50, sine 40. So what you should see is cos alpha, cos beta minus sine alpha, sine beta. Can you all see that, people? So which one of the four is it? It's number? The fourth one. You all agree with that? Remember, it's going to be cos alpha, cos beta, minus sine alpha, sine beta. So what I do is I see this angles here as alpha and beta. You all understand that? So that gives us now try and wrap it up very quickly. Okay, so what do we get here? It was alpha, beta. If it is a minus, it must be plus. Not so? So what is this going to be? 50 plus 40. Now why do you tell me it's number 4? It's the third one. No, it is number 4. You are there. Okay, now what? What is 50 plus 40? 90. And what is cos of 90? 0. Is your cos graph? No, that's sine.
Good afternoon, may I have your attention please? The following learners can please go to room 36 at the beginning of second break. In 11A it is Landa Dani, Lalita, Kelsey, Anesu, Onele, Grace Mumia, and Biuwetu. Those learners to report to room 36 at the beginning of second break. Then inter-exercise will meet in the drama room now at second break. Inter-exercise to meet in the drama room now at second break. And the following learners, if you can please come to the office: Kendall Solomon, Jordan Aronson, Setu Mabacha, and Philisandre in grade 11B. Those learners, if you can please come to the office. Our book room will be open now during second break. The book room clothing store will be open during second break. Thank you.
Okay, this is wrap this up quickly. So we have cos of 3a, cos a plus sine 3a sine a. So what we have here, what does this remind us of? Cos, cos, sine, sine. The cos rule. Not so? You all see the cos rule here? Right. Which one of the two is it? Cos rule? The first one. Why? Because I'm busy with a plus. So we must write it as cos of alpha minus 1. Are you all okay with that? So this must cos alpha, cos beta plus sine alpha, sine beta. Can you see that, people? Cos alpha, cos beta plus sine alpha, sine beta. Can be written as cos alpha minus beta. You all okay with that? So what do we get? Cos alpha minus beta. And what's your alpha angle? 3a. What's the beta angle? So what is 3a minus a? That's what we have. Okay? So I'm going to do example 4 and 5 now on the board. If you want to see how I did it, how I'm going to do it, you can stay. Otherwise you can go for your break. The homework is exercise 2, number 1. As you can see, it's straightforward. Expanding. Number 2 is what we have just done. Number 3 you should be able to do once you have the hang of number 2. I'm going to do an example now of number 4 and an example of number 5. So I want you guys to do every alternate sum out of this exercise. Okay? So like I said, if you want to leave, you may leave. Otherwise you can stay and see how I do this. Okay? Sorry? Sorry? Somebody talking? Oh my word. It's frustrating. Yeah? Is it? It's all here. Right, so let's carry on. So we're looking at example 4 on page 94. Okay. Example 4 on page 94. In each work example, you will expand the compound angle formula. So in number 4, we are told to show that sine of a plus b times sine of a minus b can be written as sine squared a minus sine squared b. So this is what we call, again, your identity. Can you see that? Now in identity, we don't take things over the equal sign. We work with the left and right hand side story. Okay? So on the left hand side of the equal sign, we have that, not so. So we have sign A plus B. But sign A plus B can be expanded into what? Sign A plus B. It can be written as sin A cos B plus sin B cos A. You all agree with that? So that I'm going to expand as sin BA cos B plus sin B, which is B cos A. Okay. And that must be multiplied by this here. Can you see that? So what can sin A minus B be written as? This can be written as sin of A cos B minus, as you can see I'm using this formula here, minus sin B cos of A. So what you should be seeing here is the conjugate P. Can you see that? Sin A cos B plus sin B cos A, and then we got sin A cos B minus sin B cos A. It's a conjugate P. It's the same as saying x minus y times x plus y. So here I can just multiply the first and the last, which is x squared minus y squared. Not so? So let's apply that then. We multiply again the first and the last. Okay. So what do we get here? Sin A cos B times sin A cos B will be sin squared A cos squared B minus sin B cos A times sin B cos A is going to be sin squared B cos squared A. But if you look at what we have on the left hand side or the right hand side of the equal sign.
Your attention please. Trust in 8A. Trust in 8A and Similarity to fill it and please report to the office.
So you see what we have.
Similarity to fill it and trust in 8A. Can you please report to the office?
We got sin A. There's sin A. But we don't have a cos squared B. Not so? And we don't have a cos squared A. But we know that cos squared B is equivalent to what? 1 minus sin squared B. Where do I get that from? I get that from the fact that sin squared B plus cos squared B is 1. Right? Likewise, cos squared A is equal to what? 1 minus sin squared A. Not so? So I'm going to replace that. So there's going to be sin squared A times minus sin squared B times. We're replacing cos squared B with 1 minus sin squared B and cos squared A with 1 minus sin squared A. We get rid of the bracket here, which is going to give me sin squared A, we're multiplying in, minus sin squared A, sin squared B, multiply out there, I get negative sin squared B plus sin squared A, sin squared B. Okay? So now we look for like terms, and here is like terms here. So what's negative sin squared A, sin squared B plus sin squared A, sin squared B? What's going to happen here? Cancel. So what are we left with? Sin squared A minus sin squared B, which is equal to the right hand side. Okay. You guys can do the sum again at home before you start number 3. Ne? Just get the last question here. And this is what the NBT would normally look like. They would give you something like this, like the sum. Remember again, it's without the use of a calculator. Okay. So they have to ask you. With regards to special angles. Okay. Number 5, they ask you to find the value of sine of 75 without using a calculator. Okay. So 75 can be made of what? 2 special angles. 45 plus 30 degrees. Not so. So sine 45. This to us should be the same as sine alpha plus beta. Not so. Sine alpha plus beta is going to be the first one there. Are you all okay with that? Right. So what's my alpha now? 45 and 30 for your beta angle there. Okay. So yes?
No, sir, I want 5 over me.
Just come put your money. So what do we get? Sine. What's my alpha angle? Okay, so it's sine alpha plus beta can be written as sine alpha cos beta plus sine beta cos alpha. So it's going to be sine alpha is 45, beta is 30, so it's cos 30, plus sine beta, so it's sine 30, cos 45. Okay, again that takes you to the special angles. So it's 45, so it's 1 root 2. The one dealing with 30 is 1 2 root 3. So sine 45 is 1 over root 2. Cos of 30 is root 3 over 2. Sine 30 is a half. Cos 45 is 1 over root 2. So that's going to give you 2 root 2 in the denominator. Root 3 plus 2 root 2 in the denominator 1. As you can see, the denominators are the same. So it's going to be a root of 3 plus 1. Okay. Do you guys understand? If you don't understand, you can refer back to the video. Rewatch this last 2 or 3 examples, and then you do for me for homework that exercise 2. You do for me every alternate sum. So it's 1.1, 1.3, 2.1, 2.3, 5, 7, and 3.1, 3.5, and so on and so on. Okay. People enjoy the rest of your day. Good morning, class. Good afternoon, class. Yeah, every alternate sum. People, you guys must talk to me, please, man. It's frustrating. Just guessing what is on your mind. I'm sure it's nothing to do with maths that's on your mind. Okay, enjoy the rest of your day. Have fun. Bye, enjoy the rest of your day. Yes, Michael.
Do you have extra things for the test?
Extra?
Extra questions for the test to do?
I can check now for you. Of the class test.
Yes, sir.
What happened to your one? Huh?
It's in my, I think it's in my other book.
Now why didn't you look after your things?
Sir,
Listen, you're still going to get a lot of things, no?
I'm going to get a file, sir.
Yeah, no. I can give you a file if you want.
Okay, you can just get one, sir.
Did you put all your stuff in there? I'm going to give it to you now. Okay, just give me a minute.
And so you don't use the video, sir.
Which video?
The paper one. You stopped it at question 5, sir.
Yeah. But remember there was 1 week you guys didn't come to class.
Yes, sir.
So that's the lesson we missed.
But I'm thinking for tomorrow, sir.
Tomorrow.
Isn't it paper 1 and paper 2, sir?
Yes, you must know both.
But now you don't.